Imagine a 735,000-pound Boeing 747 soaring through the sky. How is that even possible? Why doesn't it just fall to the ground? Today, I'm uncovering the incredible science behind flight. Before that, let's take a step back in time to understand how we got here. The dream of flight has fascinated humans for centuries. From the myth of Icarus to Leonardo da Vinci's sketches of flying machines, the journey to modern aviation has been long and arduous. The Wright brothers, Orville and Wilbur, made history in 1903 with the first powered flight in Kitty Hawk, North Carolina. Their success was built on years of experimentation and innovation. This breakthrough paved the way for the development of more advanced aircraft, leading to the sophisticated planes we see today. Understanding this history helps us appreciate the incredible science and engineering that keep airplanes in the sky. The shape of the wing, called an airfoil, also helps direct airflow to maximize lift. These forces, lift, gravity, thrust, and drag, work together to keep an airplane flying. Think about this. A Boeing 747 weighs around 735,000 pounds, yet it flies effortlessly. So what really is making planes fly? The secret to flight lies in something called lift. Lift is the upward force that keeps a plane in the air. When air moves over the wings, something fascinating happens. Faster-moving air has lower pressure, while slower-moving air underneath creates higher pressure. This difference in pressure pushes the airplane upward. This is lift. But lift alone isn't enough. To generate enough lift, planes need to move fast. That's why they speed down the runway before taking off. Pilots also adjust the angle of the wings, known as the angle of attack, to control how much lift is generated. As long as a plane keeps moving forward with enough speed, lift continues to push it upward, balancing its weight. That's why airplanes don't just fall from the sky. That's the incredible power of lift at work. So next time you're on a plane, remember, you're not just flying, you're defying gravity with science. Now that we have a grasp on the basic principles of flight, let's explore the different types of airplanes and how they stay up in the air. Not all planes are created equal, and each type has unique features that help it soar through the skies. First, let's talk about commercial airliners like the Boeing 747 and the Airbus A380. These giants of the sky rely on massive engines that generate powerful thrust, allowing them to achieve the necessary speed for liftoff. Their wings are specifically designed to handle the heavy weight, with advanced aerodynamics that maximize lift and minimize drag. Next, we have fighter jets. These planes are built for speed and agility. Unlike commercial airliners, fighter jets have sleek, narrow wings that allow them to maneuver quickly. They also have afterburners that provide an extra boost of speed, essential for quick takeoffs and evasive maneuvers. The high thrust-to-weight ratio in these jets means they can perform incredible stunts like barrel rolls and vertical climbs. Then, there are gliders. Unlike powered aircraft, gliders don't have engines. So how do they stay up in the air? Gliders rely solely on air currents and thermals, rising columns of warm air, to stay aloft. Pilots skillfully navigate these air currents, using the wing's shape to generate lift. It's a delicate balance of control and natural forces, making gliding a unique and exhilarating form of flight. Lastly, let's not forget about helicopters. Though not technically airplanes, helicopters achieve flight through a different mechanism altogether. Their rotating blades act as wings, generating lift as they spin. By adjusting the pitch of these blades, helicopters can hover in place, move forward, backward, and even sideways. This versatility makes them invaluable for rescue missions, military operations, and even filming stunning aerial shots. Each type of aircraft, from commercial jets to nimble fighter planes, gliders, and helicopters, uses the principles of lift, thrust, and aerodynamics in its own unique way. Understanding these differences helps us appreciate the incredible variety of engineering marvels that fill our skies. As we look to the future, the possibilities for aviation are endless. From electric planes to supersonic jets, the next era of flight promises to be even more revolutionary. Companies like SpaceX and Boeing are already working on spacecraft that could one day take us to Mars. Imagine a world where air travel is faster, greener, and more efficient. The future of aviation is not just about getting from point A to point B, it's about pushing the boundaries of what's possible. Knowledge is power. Don't stop now. Watch the next video and level up. Don't forget to subscribe, like, and share.